Hey guys, sorry about not being able to be here today, but I thought I could help out still with some of this. Now, first and foremost, we're going to talk about the 30, 60, 90 triangles, and what we're going to talk about with that and the 45, 45, 90 triangles is just basically that we are going to be using the same ratio to solve these problems. All right? So for problem A, you're going to use the 1 to 1, the sides are the same, and then the hypotenuse is the side times the square root of 2. For B, you're going to be looking at the 1 to the square root of 3 to the 2 as your side. So we have the short leg right now, which is the 1. So I'm going to estimate B is 2 times that, and I'm going to say A is the short leg times square root of 3. And then finally C is the another 45, 45, 90, or 1 to 1 to the square root of 2 ratio. So give these a shot and work through these real quick. In about 8 minutes, we will go through and walk through them. All right. Please pay attention to the directions up top here. We want simplest radical form, which means no decimals. All right. You guys need to simplify these radicals, find the factors, so forth, so on. All right. If you have any questions, feel free to ask and see what we can do to help you. All right, so at this time, I'm going to ask that the video be paused so that you guys can work through this. All right, so now that you guys have had a chance to kind of work on this, we got to remember our simple ratios. Our ratio for the 45, 45, 90 is the 1 to 1 to the square root of 2. Here's our first side. So right away, I'm going to cross out that x, and I'm going to say that that x is also 5. And when I say that that x is also 5, I know now that I could do two things. I can use Pythagorean Theorem, or I can just throw a 5 square root of 2 as my answer. Let's prove it, though, using the Pythagorean Theorem. I get 5 squared plus 5 squared equals y squared. As I work through this, right, I get 25 plus 25 equals y squared. 50 equals y squared. Now I have to take the square root of both sides, right? And the square root of 50 comes out to a decimal, so I want to factor out 50. I get 1 times 50, 2 times 25, 5 times 10. And that's probably the only factors that are there. And I know right off the bat that this is a perfect square, so we're going to use that one. We're going to go square root of 25 times the square root of 2 equals y squared. Once we have that, we know we can factor that out and get 5 square root of 2 equals y. All right, so that's how you would solve that. That's the basic steps in solving that one. All right, it's just like what we did yesterday. Next, we have a 30, 60, 90 degree relationship here, with this one being our 30 degree side. So what that means is that the 12 is actually our shortest side in this ratio of 1 square root of 3, 2. All right, so because that is there, we know that that's going to be 12. And I can make a conservative guess and say, okay, well, if this is a ratio here of 12, right, I know that the b is going to be 24 because the b is 2 times the short side. Now, I can make the estimate once again that this is going to be 12 square root of 3, just based on my ratio. But let's prove it out using the Pythagorean Theorem. All right, so I get 12 squared plus y squared, or a squared in this one, equals 24 squared. All right, so once I have that set up, I know 144 plus a squared equals 24 squared. 24 squared is 576. Subtract 144 from both sides. And you get a squared equals 432. Now, here's where it gets a little tricky because we got to factor this out some way. All right, so I'm going to take the square root of both sides, and I need to come up with factors of 432. Now, you can use your perfect squares, and I'm going to start writing perfect squares just over here. All right, not 1. I don't know what I'm thinking there. Let's erase that. Let's go back. Let's start with 4, 9, right? 16, 25, 36, 49, 64, 81, 100, 121, 144. Alright, and as the list goes on, we can keep going for just seemingly about ever. But we will kind of stop there. And now let's just figure out what factors have perfect squares in them here. So we'll go 432, and we'll divide it by, say, 4. And that comes out to 108. So we have 4 times 108 as an option. Let's try 432 divided by 9. We get 48, so 9 times 48. Alright, let's go 432 divided by 16 equals 27 times 16. Alright, let's go 432 divided by 25. I'm going to estimate doesn't work, so we'll jump up to 36. 36 times 12. Alright, let's keep working here. Let's go 432 divided by 49. Decimal. Let's try 64. 432 divided by 64 is also a decimal. Let's try 81. 432 divided by 81 equals decimal. 432 divided by 100, I know is not going to work, so we'll jump up to 121. Decimal. 432 divided by 144, 3. So 144 times 3. We'll try 169 just to see, but I'm thinking that because 432 divided by 2 is 216, that we are actually at our highest one right here, and that's what one we'll use to factor. So we'll have a after the square root equals the square root of 144 times the square root of 3. So what we come up with is a 12 square root of 3 as we prove that out. Now you can look and see, and how simple it is just to look and realize that that ratio is going to hold true. Alright, here's your last one for the warm-up. It's a 45, 45, 90. So we have a 1-to-1 to the square root of 2 ratio. Alright, so we'll start with our two sides. We have 2 and 2. They give us that, so I'm going to estimate that this side is 2 square root of 2. And I'm ready to prove it out to you. 2 plus 2 plus equals e squared. 4 plus 4 equals e squared. 8 equals e squared. Well, let's figure it out. Factors of 8, right? 1 times 8 and 2 times 4. Only one with a perfect square is this one, so we go back and we plug that in as 2 times the square root of 4 equals e. Okay, so once we figure that out, we get 2 square root of 2 equals e. Alright, so as you guys look at this stuff today, it's really important that we remember exactly what it is that we're doing. And it really just boils down to remembering this simple ratio. 1 square root of 3 to 2 for our 30, 60, 90s. Alright, and as you work through that, you can see how they prove this all out. And it's pretty straightforward and pretty simple once we get it all done. Alright, so if we had to practice it. So when you take a look at something like this, this is actually really simple. You go 1 square root of 3, 2 as your ratio, and now that you have this, that's your 60-degree side, you know that y is no longer y, it's just going to be 6 because it's, well, you know, if this is the long side and it's the square root of 2, you make that 6, you push this in as 12 because it's 2 times that, and you're done. So y equals 6 and x equals 12. Now if you wanted to plug this into your Pythagorean Theorem and give it a shot, we can plug in, you know, our two estimates here, 6 squared plus y squared equals 12 squared. Okay, so we get 36 plus y squared equals 144. Subtract 36 from both sides. Alright, we get y squared equals 144 minus 36 is 108. And then you have to factor out that 108 and come up with some of those factors. Now you probably just want to look at perfect squares. So 108 divided by 4 would be 27 as one. Okay, and then as we work through that, we can say 108 divided by 9 is 12. 9 times 12, right? 108 divided by 16 doesn't work. 108 divided by 25 doesn't work. 108 divided by 36 works, and that's 3. So 36 square root of 3. Alright, well, not quite yet, but 36 times 3 definitely is there. So what we do is we just come back over here, we plug in y equals the square root of 36 times the square root of 3, 6 square root of 3 as our answer. Everything works out. Alright, so alright guys, so when you come to this, remember our simple ratio of 1 to 1 to the square root of 2. I'm writing 5 because that's in our problem here. Alright, but it's 1 to 1 square root of 2. So when you take a look at this idea, right, it's pretty simple for us to look and see, whoa, I can do that from the leg because they're the same, but I don't know the legs here and there's no square root sign. I can't just cancel it out. And what you can easily do with this, though, is just realize basically that if you are going from the hypotenuse to the leg, it's really 5 divided by the square root of 2. Now, that is not simplest radical form, so you cannot submit an answer like that. Right? And then 5 divided by the decimal, we're getting messy. Keep the radicals in there. They're easy to deal with. Right? You just have to multiply by square root of 2 over the square root of 2. And when you do that, what that really looks like is these become 2. All right? And then that just carries over. So 5 square root of 2 over 2. And that is your answer. Both the legs are 5 square root of 2 over 2. And if you plug that in and work on that decimal, you'll be able to see that it works in every which way. And thank you guys for watching. Good luck on your work today. If you guys have questions, you guys can ask me tomorrow. Take care. Have a wonderful night, and I will see you guys later.